humanOS. Learn, master, achieve.
Hi, this is Dan Pardi, and today I am going to be interviewing two authors of a paper that just came out in the American Journal of Clinical Nutrition, which is the most prestigious nutrition journal in the world. And the paper is entitled Paleolithic Nutrition for Metabolic Syndrome, Systematic Review and Meta-Analysis. And the authors on the paper are Eric Mannheimer, Esther Van Zuuren, Zibic Fedorovich, and Hanno Pijl. We have two authors with us this morning, Esther Van Zuuren and Hanno Pijl. Hanno, if you wouldn't mind starting off and giving us an introduction of yourself, that'd be great.
Sure. Well, first of all, Dan, thanks for having us. And I'm an endocrinologist, meaning a doctor who treats patients with hormonal disease. I'm a professor of diabetology in the Leiden University Medical Center. I have years of experience with treating people with diabetes. And I did quite some research on pathophysiology, so the disease course of diabetes over the years.
And Esther, if you could do the same, we'd love to hear more about you.
I'm actually a dermatologist, so I'm more busy with the outside of the body. But outside office hours, I have this particular hobby, which is called doing systematic reviews.
You know, Hanno, I know you've been interested in this Paleolithic nutrition pattern for quite some time. Maybe tell us about what the pattern is and what you find interesting about it.
You know, there is not one Paleolithic diet, actually, because what we mean by Paleolithic is actually in the Paleolithic era, which is from about 2 million years ago until 10,000 years ago, until the advent of agriculture, people had a quite different dietary pattern than the pattern we have today. And in fact, since the advent of agriculture some 10,000 years ago, humans started eating huge amounts of cereals, of whole grains. Another thing that we started eating as from that time is dairy, because as you can imagine, it's very, very difficult to get milk from wild animals. We only started harvesting milk from the time that we domesticated animals. So from that time on, that was the first moment in human history that adult people started using dairy. Because before that time, babies, children got milk from their mothers, but adults never touched a dairy product. What is meant by Paleolithic nutrition is basically the food we ate prior to the advent of agriculture, meaning that this was basically vegetables, fruits, nuts, meat, and fish. That's the basis of Paleolithic nutrition in varying proportions. So there were some people in the Mediterranean area, for example, who ate more vegetables, while in the northern parts of the world, people ate more fish and meat. So it was variable, but these are the basics of what we call Paleolithic nutrition today.
And Hanno, because this paper looked at metabolic syndrome, could you also give us a primer on that condition?
So the metabolic syndrome is a cluster of metabolic abnormalities that often go together. There are normal weight people with the metabolic syndrome, but usually people with the metabolic syndrome are overweight. And the syndrome actually comprises a cluster of components, including high blood pressure, high blood glucose levels, but not in the diabetic range. People with the metabolic syndrome have low HDL levels and triglycerides are high. And then there's the last component. There's 5 components. The last component is the waist circumference is 88 centimeters in women and 102 centimeters in men. The definition by NIH says that you need to have 3 or 5 components to have the metabolic syndrome. But in fact, every single component on its own increases the risk for chronic disease, in particular cardiovascular disease and diabetes. So what we did in the review was we took studies that looked at people who had at least one of the 5 components of the metabolic syndrome, who were treated with either Paleolithic nutrition or a control diet. And the control diet was either a diet according to national guidelines for the general public or guidelines for diabetes patients. They differed. There were 4 studies and every study had its own control diet. And in 2 of the 4 studies, there were national guidelines. In one study, they used the guidelines for diabetes patients as a control diet. And the 4th study actually used Mediterranean diet as the control diet.
So, Hanno, since there were differences in the diets across the 4 different studies, were they similar enough to be comparable and then considered one control diet?
Yes, they were roughly similar.
Okay, that's good to know. And Esther, if you wouldn't mind doing the same, I'm sure a lot of our listeners already know that a meta-analysis pulls together a lot of data from different papers and then analyzes multiple papers altogether. But there are details about how this is done that you can shed light on that are really valuable for the listener to understand this process better. So what do you look for when you're choosing what paper to include and not include in a meta-analysis?
You look at how the study is designed, how the study is conducted, and how the study is reported. If all the people that are included in the study are also accounted for at the end of the study. Because when there are a lot of dropouts, you want to know why they dropped out. Because, for example, if one outcome showed very bad results and were not reported, we call that reporting bias. So all those elements were checked by us. And also we looked at were the groups comparable at the start, or was, for example, the control group in a much worse state than the paleo group, so to speak. So these are all elements we looked at, and then we took the data of all these studies together and we did our analysis. Every step of the way is done independently by another review author. And after that, we could combine, or what we also call pool the data. So we always took the first time point in which they reported data.
3 of the 4 studies just gave dietary guidance. They were supported on a regular basis by dietitians, and they have to get their food themselves. And there was one study that catered food for 2 weeks, so delivered them at home to the subject. But this was only for 2 weeks, of course, because it's very laborious.
Yeah, such a highly controlled dietary study is so challenging, but it's always interesting to me with dietary research. Is the study actually reporting on and studying what it claims to? But that's a side point. So, Hanno, can you tell us about the results of the meta-analysis?
We found that actually every single component improved more in people using the paleo diet. There was a greater decline in blood pressure, both diastolic and systolic blood pressure. There was a greater increase, although it was not statistically significant, in HDL cholesterol. And then there was a greater decline in the triglyceride level. There was a greater decline of waist circumference. There was a greater decline in glucose. It was not statistically significant, just like the HDL. But waist circumference, blood pressure, and triglyceride levels declined significantly in the people who ate Paleolithic nutrition. So this was really a surprising and promising result.
One of our secondary outcomes was also weight loss, and it also significantly decreased weight loss more in the paleo nutrition group. In a short time, it was between 2 and 3 kilos difference.
I thought it was really interesting that one of the studies, the study by Boers et al., tried to prevent weight loss. And this was the study that was using the pre-prepared meals. And what they did is that if somebody started to lose weight spontaneously, which means they weren't intentionally doing it, but they were eating the meals and they were losing weight, then they actually gave them additional snacks to keep their weight stable. A lot of the different aspects of metabolic syndrome, so blood pressure, triglycerides, etc., will improve favorably simply with weight loss. And this study wanted to look at what are the nutritional effects on these parameters, not whether or not it can induce weight loss. But the weight loss itself is really meaningful, and that is something that has been shown time and time again, that a Paleolithic diet has a favorable effect on body weight. And this is likely due to the high satiety reported from the quality of food, so higher in protein, higher in fiber, and possibly with the exclusion of certain things that might interfere with adequate energy regulation signal. For example, things like gluten interfering with leptin signaling has been reported by some of the authors that were included in the meta-analysis.
And I think it's also for patients often a lot of the metabolic components are not directly felt by a patient. But if you are weighing yourself regularly and you see you're losing weight, it also motivates people, I think, to continue.
We now have a meta-analysis that adds to the literature base. Obviously, more research is needed. What is the future for paleo?
Well, I think, first of all, we have to know whether the diet works as well in the long term. I think that's critical, but because obviously the treatment of metabolic syndrome is not a treatment of 2 weeks or 6 months. It's basically a lifelong treatment. So that's an important thing that we have to figure out. Can people actually sustain the improvements in the long term? And then another important thing is there's at least 4 important aspects of paleo nutrition that may be important for its metabolic effects. First of all, there is relatively little carbohydrate in there. In particular, there's no sugar. And we know that sugar consumption is bad for metabolism. It's bad for glucose metabolism in particular. The zero amount of sugars in paleo nutrition may be an important aspect of the nutritional pattern. Another thing is that there's very little salt in there, which obviously is important for blood pressure. A third aspect is there is relatively a lot of omega-3 fatty acids, and omega-3 fatty acids reduce inflammation. And we think that one of the triggers of the metabolic syndrome is a chronic inflammatory response to nutrition, or their effect on metabolism is readily explained by modern nutritional science. However, we don't know whether the omission of whole grain consumption is important in the metabolic effects of paleo nutrition, because there is lots of epidemiological evidence that suggests that whole grain consumption actually prevents diabetes and improves metabolism. Now, I think future studies should figure out whether the lack of cereals, the lack of whole grains, is an important component of the Paleolithic nutrition in terms of its preventive effects on metabolic syndrome and type 2 diabetes. Actually, I forgot to tell you that the metabolic syndrome is a kind of pre-diabetes state. So lots of people with the metabolic syndrome end up having diabetes. Epidemiological evidence suggests that whole grains are good for prevention of diabetes. And I don't know if the lack of whole grains is important in the Paleolithic diet. And another thing is the lack of milk products. So epidemiological evidence suggesting that in particular fermented dairy is good for the prevention of diabetes. Is that important in Paleolithic nutrition? The core feature of Paleolithic nutrition is the absence of processed food, the absence of salt, the absence of sugar, and the presence of omega-3 fatty acids. But whether whole grains and dairy are important is something that we have to find out in future studies.
Since I've become compelled by the idea of Paleolithic nutrition by reading some of your early work, Hanno, and then reading subsequent pilot studies and research that's followed on to that, I've wondered, what are the unique characteristics or features that are causing the beneficial effects? Is it the exclusion of something? Is it the inclusion of something? Or is it the entire pattern altogether? I don't think the answers to those questions are yet known, but I think a meta-analysis like this that shows clear differentiation between standard protocols is enough to stimulate additional research into Paleolithic nutrition, which will both have longer trials and more people, but hopefully will also identify what are those characteristics. We don't want to exclude any food types that are health promoting. Now, sometimes from a behavioral perspective, excluding a food type altogether is beneficial, because if there's in that food type some good, some bad, removing it altogether and drawing a bright line around it and saying, no, you don't go there, can help people make better choices. That is a technique that you can use to foster compliance. From a nutritional perspective, we need to know what is good to include and what is not, and then start with our basis there and include everything that is health promoting. And that might include actually aspects that are currently considered taboo on a paleo diet, but might be completely healthy for us. Our legumes, our whole grains, is even fermented dairy, is that health promoting if eaten in the context of a whole food diet that's low in sugar, that has the appropriate salt to potassium ratios, the appropriate omega-3 to omega-6 ratios. These are questions that I cannot wait to get more answers to. I've concluded so far by the available evidence is that it seems to be very healthy from what we know, but it also might be overly restrictive. And Hanno, if you could maybe speculate about, we talked about what metabolic syndrome contains. What are the components of it? What is it's pre-diabetic, pre-cardiovascular disease? What do you think are some of the mechanisms involved in its generation, and how might those be ameliorated by using a Paleolithic nutrition program?
I think we have to go back into our evolutionary history to answer that question. About 2.5 million years ago, our ancestors switched from a diet that comprised virtually only carbohydrates to a diet that comprised at least 50% meat and fish. So this was because there was a huge climate change in the area in Africa where they lived by that time. And they were forced actually to move to the water side. And they started eating fish and meat, and they started hunting. In the course of the million years after that diet change, we adapted. And we adapted to a diet that was relatively carbohydrate poor. And why did we adapt? Because carbohydrates, and glucose in particular, is of great importance for the brain. Our brain consumes glucose as the primary fuel. So the relatively little carbohydrate that we consumed, all the carbohydrates we were able to eat, had to go to our brain. And therefore, we developed insulin resistance. So insulin is critical in storing glucose in muscle and liver and other tissues. Now, if you're insulin resistant, you don't do that. And it leaves glucose available for combustion by the brain, right? So insulin resistance is actually an adaptation to a diet that is relatively poor in carbohydrate. Then came agriculture 10,000 years ago, and humans started eating huge amounts of carbohydrates again. All those grains are very, very carbohydrate rich. And the other thing, the Industrial Revolution of 250 years ago made us eat huge amounts of those grains. And so there's no need for insulin resistance anymore. In fact, it's a problem now. When people with insulin resistance eat huge amounts of carbohydrates, they can't get rid of their glucose. So I think the adaptation that we went through over the course of millions of years is now disadvantageous because we eat too much, and we eat too much grains and carbohydrates in particular.
You know, I know there's been some arguments about are tubers paleo. And I know Karen Hardy came out with a hypothesis recently, said that the importance of dietary carbohydrates in human evolution, and that it was meat consumption that originally advanced the brain growth in humans. But ultimately, her hypothesis is that 1 million years ago, spreading of copies of the salivary amylase gene, and then possibly pancreatic amylase, plus cooking, which enabled us to break down the crystalline structure of tubers, made tubers a much higher part of the diet. Some people seem to do very well on a high carbohydrate diet, but not if those carbohydrates are rapidly digested processed foods, but if they are contained in roots and tubers. I'm curious to know your opinion. Is a carbohydrate, or is there kind of good sources and not so good sources? And can you do well on a high carbohydrate diet as long as it's coming from a whole food source versus something that has been processed?
That's a critical distinction. I know of Karen Hardy's work. In fact, I totally agree with her that humans needed carbohydrates to feed their brains. However, the sugars, the processed carbohydrates that we eat today, and the amounts we eat today are really superfluous. So processed carbohydrates, one should avoid. Processed carbohydrates are not good for anyone, but some people can handle them better than others. So people who have genetic architecture that makes them insulin resistant once they grow obese, they should not eat processed carbohydrates. They should modestly consume unprocessed carbohydrates, whole foods with carbohydrates, but not processed carbohydrates. And people who are not obese and who have perfect insulin sensitivity, they can handle the consumption of even some processed carbohydrate better than people with obesity and the metabolic syndrome.
similar to the conversation we were having earlier, you might not detect it for a while, but if you maintain that pattern over the course of years to decades, your risk of ending up with some conditions that are unfavorable to your health are going to appear. Like you said, your genetic architecture could limit that, but you're certainly putting yourself at more risk. I tried to make that distinction in an article that I wrote recently about the number one source of calories in the United States is grain-based desserts. So highly processed, lots of sugar. The health consequences would be a lot different if that was sweet potatoes and starchy vegetables.
Oh, yeah, you're absolutely right.
It's interesting to think about, some of the core fundamentals of what we're dealing with when we maintain a lifestyle pattern, including a nutritional pattern that is foreign to our physiology. A lot of the elements of metabolic syndrome have to do with insulin insensitivity. This other term, chronic systemic low-grade inflammation-induced energy reallocation syndrome. But it's the idea that low-grade inflammation, which can come from more things than just nutrition, but certainly nutrition, affects how energy is allocated in the body in a pathological way. And insulin resistance is one marker of that. But you also see hyperactivity of the sympathetic nervous system and the adrenal axis. And insulin resistance happens in an asymmetrical fashion in the body. And so one of the reasons why we become salt sensitive, renal sodium reabsorption is not affected by insulin resistance. Right. But nitric oxide mediated vasodilation, or how the blood vessels will vasodilate to deliver blood, that is affected. And so because we're starting to produce more insulin because we're insulin resistant, then you're getting overstimulated some places, under adequate stimulation because of resistance in others, and you end up with salt-sensitive hypertension. And that's just one kind of mechanism by how things break down when the body ends up being assaulted by low-grade inflammation over time or even immediately. Anyway, it's fascinating to understand the mechanisms. It's fascinating to see this research. I know that this is really difficult, methodical work that you've done, and it's a very valuable contribution to the literature. And so thank you. And one thing that I also found interesting with this meta-analysis is there's an ongoing nature to it. So you also did an analysis of 4 different databases looking to see what research is coming down the pipeline. So Esther, will there be basically a reanalysis at some point when more data is available?
I certainly think if there are more studies, and I think as paleo nutrition is now so hip and so many people are interested in it, we know already that there are a few ongoing studies, and certainly what we always do with the systematic reviews I'm doing for Cochrane, they have to be updated every 2 or 3 years. So certainly I think we will update this review as well. But it will take time, even with some adjustments that, for example, some fermented dairy products are allowed. And for example, some whole grain products might not be that bad, but we still don't know at this stage. So it might be that in the end, instead of strict paleo, there might be some adjustments that also make it easier for people to stick to it if they can have some more beneficial whole grains or some fermented dairy products. So it's, I think, an ongoing story.
Well, I think that's a perfect place to end. And I would like to thank Dr. Esther Van Zuuren and Dr. Hanno Pijl for joining me today and discussing this meta-analysis, which adds meaningfully to the literature on Paleolithic nutrition. So thank you so much for listening, and I'll see you next time.
Thanks for listening, and come visit us soon at humanOS.me.